Here's the SpeedyBee flight controller. Looks like a very good quality product. I like the look of this machine. It's the most extensive quick install, Chinese and English. Quick start guide. I have never seen a quick start guide that comprehensive. This is beautiful. So in the box we have the flight controller itself, which is this circuit board, which has the microprocessor there, SD card on board to hold your logs. It's got the connectors for different digital devices like airspeed sensor, lots of connections on there. Then we have the power distribution board. Nice big solder connections. This is a small mini controller, and these are great large pads. Even a novice soldering person like myself can make connections on this thing quite easily with a little bit of soldering flux. Here's the USB connection device that allows the flight controller through a USB connection to your laptop or whatever device you're using to communicate with it. And there's the connector that connects onto the flight controller itself. Then on the bottom of the box we have the pins, two kinds of pins, a 90-degree set, and of course the straight vertical set. Depends whether you like to plug your servos, etc., and your devices into the board vertically, or whether you want them to come in from the end. So that's a couple of sets of pins. We have the brass, it looks like, and little screws, the standoffs that go between the different boards, like so, I guess, yeah. They go into these holes here to hold your flight controller together. We have all of the cables. What a great selection of cables, all the different cables you need to connect to this flight controller. And we have another bag of cables, and of course a capacitor for the power distribution board. And we have two different covers for it. Depends which way, we'll see that in a few minutes. Depends which way you want to cover it. They've got two separate covers. Very complete setup from SpeedyBee, and I like the look of this. Soldering the power distribution board. That's the one that has the letters F405 easy on it. And I usually don't solder on the component side. I'll solder on the other side, because if there's any spill onto the components, it could disrupt the component side. So we'll start off by putting on the battery cable. I've already got these tinned on the end, so we'll give a little bit of solder flux on those two pads, this being the negative pad and the positive pad, and we'll tin those a little bit. And then we'll just solder each on here. Okay, that looks pretty good. I think that's going to do it. Now we'll run a cable from the flight controller. These pads right here are for the escape. That's the escape power provided from the flight controller down to the escape. Notice I'll do all this soldering before I even assemble any parts of the board. It makes it much easier. So I got two little cables pre-tinned already for the connection to the escape. And the escape, as you remember, is this, and I since put a little heat shrink on there to cover this cable. You just need a matching female to go into that male cable. The power always has, I always use the female connections for the power. Much more difficult to short out than a female where something could get inside and short those connectors. So the power cable always has the female connector. That's the way I do it. So what we need to do is connect the escape power. And you'll see here we have two pads for escape power. We have two negatives and two positives. So we've got escape power for two different escapes here. Now, the way they show it in the diagram, and that makes sense, is you'll notice here if you use the, as you look at it here, the rightmost positive pad for the power to the escape, then you should use the rightmost negative pad. I'll probably use that, I think I'll use the negative on this side, that's being the first one. I'm only using one escape, and the positive pad right there. So we'll go negative, positive that way. So the negative will go on this one, and the positive will go on that one. Now, what we need to do first to make it a little easier is make the connector solder joint first. And the positive is always the square side of these connectors. The side that's made like a house is the negative side. Okay, so let's get that soldered together. Do the positive cable first. A little bit of flux. We'll tin that guy up. I already have the wire tinned up. Don't think my iron is really that hot, but that looks like a good joint. And we'll do the negative side in the same manner. Okay. Now we'll have to solder that onto the flight controller board. You want to be careful when you're putting these pincers on the board that you don't connect any little components on the other side. Just be sure that the pliers of this helping hand is on the bolt holes only. There we go. So the escape on this side and the positive on that one. Okay. We'll do the negative one first. Okay. All right. Now, what I forgot to do was to put this little sleeve on right here. But I prefer to use heat shrink anyway. It's a little lighter maybe than this. Plus these tend to come off a little bit. I tried it on the battery one here and it's not too bad. So I'll get a little piece of heat shrink and we'll do that now. All right, I've got the heat shrink on over the connector. So we'll just apply a little bit of heat to that, shrink it down. That makes a very nice difference between the battery cable versus the escape. So later on in life, if you forgot which one is which, now instead of having a black connector on each and they look exactly the same, you can actually take a marking pen and write on this heat shrink plastic quite easily. So there's the power distribution board wired. Let's take a look at the boards now. We have these pins that we have to solder on the board. There are 3 rows of what I call servo pins, or whatever device you're going to use to stick onto the board to power up different devices. And on this power distribution board right here, you'll see there are 12 little pins right here, female sockets, I should say, and they fit onto these male pins right here. So to find out which side of the board is which, just use that as a reference, and then you can just set that onto those pins like that. See if I can get it in there. There we go. And then the board is starting to get its layers now. So these pins will go along here. The signal pin on the inside, the red one, the power pin on the middle, and then the ground or the black pins on the outside. So right here, if you look a little carefully here through that notch right down there, there's 4 pins right here. And those are for connecting something like a TBS crossfire. So I usually start with the inside pins first. It makes the job a little easier. So these pins will be soldered to the board right there. These 4 right here. If I can fit them in here. They don't want to go tonight, I think. There we go. Like that. And then you solder on the other side of the board, obviously. And then you would put the next row, the yellow signal pins, and the next row, the red power pins, the voltage pins, and then the ground pins on the outside. So when you get that done, the bottom plate of the flight controller, they got 2 of them. There's a custom plate, which is used if you're going to have the flight controller installed in the airplane upside down, not right side up. So then you would use this custom board, because that will then give you room on the top to stick the pins up this way. So the pins wouldn't be on that side if you have the flight controller upside down the plane. You will solder them on this side of the board, and the solder would be done on this side. The soldering, I should say. Okay, I'm going to use the standard board, which is this one. And that guy goes on like this. And then you see those pins are going to be covered because they're sticking up on this side of the board, which is means the flight controller will be installed right side up. Okay, so let's get the soldering done with these pins, and we'll come back and have a look. We're ready to put this stack together. I have the soldering done on the pins, the 4 rows, the one for the TBS crossfire and the one for the servos and other devices that we're going to connect to the board. Got my solder all done. When you finish soldering, better to take some baking soda, probably half and half with water, make a very light baking soda paste, and give it a good scrubbing. And then clean the brush off in clean water, and then clean the baking soda off. Just be careful you don't get too much water on the board. Just hold your finger or maybe a cloth or a piece of paper right around there while you scrub the soldering joints out. Okay, before we put this together, there's only one voltage power consideration we should look at on the power distribution board. Since this is the plug and play and you have to provide your own VTX, probably you should look at this if your VTX is sensitive to voltage, like it's only a 5-volt VTX in camera. This power connection bridge right here, you see it's now on battery power, because most VTXs run, 7 to 24 volts, I believe. And I'll be running this on 4S, which is 14.8 volts, so I'm well within the range. If you have a sensitive VTX that's voltage sensitive, lower than 7 volts, probably you should unsolder this and solder it on the left side. There's 3 little pads here. It's now soldered on the 2 right ones. Okay. So I got the standoffs here. I've already got 3 of them on. What you do is you put the little standoff brassy thing with the leg on it, the screw part, into that hole on the bottom. Looks easy, don't it? Right in there. And then take the long brass standoff, which has female connections on both ends and just screw those two together. I usually like to use an X-Acto knife when I do that because it's kind of difficult to get in there with those pins in the way. So there we go. Just take an X-Acto knife and without gouging out the threads in that female connection end, just screw that down a little bit like that. Now, the extra one fell out. They give 4, so I guess there's an extra one in the package. Okay, so having done that, we can now put the bottom plate on the whole thing. And that goes on like so. And we have these little black screws here that hold the bottom plate on. And by the way, when you put the brass standoffs on, you don't have to tighten them a lot because there's going to be a screw at the bottom here and on the top, so you can screw them both after and tighten the whole assembly. Okay, that's the extra one. Here's another screw that'll go in here. Man, those things are small, eh? Screw that down. And then the other one. When you're doing your soldering, probably better to use a tiny little 1 millimeter soldering wire. If it's a little too heavy, it's going to be difficult to solder all those pins together without making a mess. But some people do it. Some people, I'm trying to put that in the wrong hole. Here we go. This one will do. Screw that one down like that. Now we can put the power distribution board plugged into those little pins we saw earlier and into the female part right there, like so, and just push it down. And then we're ready to put the screws in the top, like so. No, it's not like that. I must have, misaligned these. I didn't get those in right. Okay, there we go. Better to line up the holes where the screws go and then the pins will follow. There we go. Okay. And this one. Not easy to get in there. There we go. Oops. Okay, I'll do this guy. There. And why wouldn't that go in? It's lined up. There we go. And one more. Now, these will be tightened later. And if you ever want to get back at those solder connections that change your voltages, you can always take the bottom plate off. They're all under the power distribution board, which is on the bottom of the stack. So there's the flight controller wired and ready to be tested before we put any voltage on it. And we'll take a look at that, the testing of the board, next. I have the capacitor installed. The capacitor goes on like so. The side of the capacitor has a gray stripe on it. That's the negative leg. So the negative leg, as you see, goes on to the negative pad of the escape wire, and the positive side goes on the positive escape leg. It goes across the escape. Okay, and I've since put a little bit of heat shrink on there to keep the capacitor from wobbling around. Now, an interesting little thing about this board, the only thing I really don't like about it is there is an SD card slot in here where you can record your logs, and of course you take the logs out and you can load them up onto Google Earth with a conversion program from GitHub, and you can actually see in 3D on Google Earth the path of your plane after the flight. Now, the problem with this little flight controller is that little SD card slot reader is in this part of the flight controller, and it must be loaded from this end. Sorry, it must be loaded from, let me see, which end is it? No, it's loaded from this end. So if you did build the flight controller in the upside down configuration, where the pins would go the other way, it would give you a little bit more access to load the card, but still you'd have to go all the way in. So what I'm going to do, I don't take it out very often, is I'm just going to remove the top plate here. And we'll have a look at what needs to be done to put that SD card in. It's pretty straightforward. It's like a normal SD card. Why they designed it this way, probably, I'm guessing, is because of the space requirements on the board. However, if they had faced it out the other way, it would have been much easier to load it from the capacitor under the power wire side of the board. Now that little SD card goes right in there like so. You just shove it in there like that. And there it is. Loads like that. And then you just put the top of the board back on like so. But to get it out is going to be much easier. You could stick an X-Acto knife in, I guess, on the side and just push one of these little legs here, and then go in the other side and push it the other way. And you keep doing that until it would come out. But it's still an inconvenient place to put an SD card. That's really the only thing I don't like about this board. At this point, it's a good idea to run some power through the flight controller board before we do any more work, just in case the board would be defective. I've never seen that in a board. I've built a few of these, but just in case, I've got what's called a short saver here. It's a little device that, if there was a solder short that I installed on the board when I was putting it all together, which would be kind of a disastrous thing if I put power in here and there's a short somewhere in the board, it would ruin the board. So this kind of saves the board if there is such a happening on the board. And you plug that in there, and we'll put power to the board, see what we got here. There we go. We should get the lights coming on right here. There we go. There we go. We've got lights on the board. Power's going through. Okay. Now let's just take a radio receiver and see if there's power on the servo pins here. We could put it on any of those as long as we've got power in the the little frisky receiver I have here, just to see, and we've got a servo attached. Take the transmitter and run some power through there, and yep, we've got power going through. So at least we know now we've got basic power going through the board, and that all of our work was not for naught. Okay, next what we'll look at is connecting the different cabling, and we'll see that in a couple of minutes. Earlier we discussed the possibility of changing the power connections on the power board so that if you had a VTX that was sensitive to high voltages, you could bridge the solder gap. That's covered in, I think it's my second video. Today we're going to look at another possibility. You could always, using the connector of your choice from these packages of connectors, connect the VTX into the VTX port, which is right here, that being that one right there. And if the power is too high, usually the camera is the one that's only 5 volts. What you could do is take the voltage off of your VTX. This is a VTX without the antenna on it. This is an old Eachine 805 I had, which is not a bad unit. I have 3 of them. The power can be taken off of this, so you can power your VTX on the flight controller, and then instead of powering the camera off of the flight controller, you just take off the red wire. You could still connect the camera to the flight controller, but use your power lead off of the VTX, and you'll see right here, if you look at here, there's a camera power of 5 volts coming off of this guy right here. So you get your ground, your power, and your signal. So you could take the power off of this unit or your VTX for your camera. That's another option. Now the other cables that go in here are the camera right here, and of course if you've got a digital VTX, like a DJI unit or some such thing, you could always use this connector right here, and they do provide the connector here. What they are basically connectors that fit into the power control board, and they have a pigtail on the other end that are soldered, so you could connect this into the flight controller board at this end right here under the cable, and just solder the appropriate ends to your unit on the other side, your device. Now you notice I put the capacitor on the top of the wiring here. I didn't think it was a good idea to put it in here, because then it gets in the way of plugging into these output peripheral connections right here. Plus it gives more air across the circuit board if there's any heating at any time or anything like that. Okay, so that's about it for connections. We're going to see a lot more about connections when we put the actual device in the aircraft and connect them up. So if we want to flash the board, that is, install the firmware on the board so that it will communicate with iNav configurator, so we can configure the board for the airplane. This little USB interface is with the SpeedyBee kit, as well as the interface cable, and that cable goes in here. It's the largest cable in the kit. It has many wires on it. I haven't counted them, and it goes into that port on this side of the flight controller, which is the side which has only one port on it, the other side being the port for an airspeed indicator. Okay, so you'll need that. Plus you'll need a Type-C connector with a USB Type-B on the other end to plug into your laptop or whatever device you're going to use to burn the firmware into the flight controller. this is I use my, actually my old Toshiba iPad Type-C connector. It's a charge cable for it. That goes right into the Type-C connector on the interface board, and so now we're all ready to take it to the laptop and download the firmware. Okay, you're going to need iNav configurator, so download that from GitHub. It's called GitHub. If you go to Google and just type in iNav, you should see down here somewhere iNav configurator 7.1. Just click on that. That will take you to GitHub. Click on the first one here, iNav configurator in GitHub. And you'll see the 7.1.0 release candidate come up. There are releases that are stable. You can go to 7.0.1, which is a stable candidate, I believe, and I just use the latest one. And all you do is you scroll down here to assets. You'll see assets right here. Just click on that. And in this case, I'm running Windows, so I'm going to go down to Windows 64 7.1.0. You just click on that. That's the whole zip. This is the exe. This is the whole zip. I usually download the whole zip. And then you go to your downloads page, and you move this iNav configurator zip file to the directory of your choice. All right, take your flight controller, this guy right here, and on the other end we have attached the USB with the Type-C connector. And there's a button right there, black button, just on the side that has bar marked on it. You hold that button down, and while you hold it down, plug the USB cable Type-B into your laptop. You'll see a green light flash like so. Now you can put this away, and you click on the application we just installed called iNav configurator. And if you put it as an icon on your main screen, it'll be right here. Click on that, start that up. Now it should see that the flight controller is in DFU mode. You see right here it says DFU. This is in flash mode. Don't connect. Don't need to do that yet. Go over to the side, click on firmware flasher right here. Type in there, or actually you can look for the target. I'll have to put myself online here first, just a second. I was offline. Connect. You must be connected to the internet to do this. Okay, and go over to firmware flasher. Try that again. We'll just refresh it. Choose a board. We're looking for SpeedyBee wing. That would be the SpeedyBee F405 wing, which is right here. SpeedyBee 405 wing. Don't use mini. Any of these, use the 405 wing. Click on that. Then you have to say which version do you want. There are different versions. We're going to use the 7.0, which is the stable one. This one right here. You want these all clicked to on. No reboot. You don't want to reboot after. Flash on connect. We're going to flash the chip, and we're going to do a full chip erase, because SpeedyBee has probably installed version 6 or some older version on the board to allow us to talk to it through the iNav configurator. Then down here at the bottom on the right-hand side, if you've downloaded the hex file and you've unzipped it and you see it, you could load it from your disk drive. It's a hex file, .hex. Otherwise, just load it online like so. Give it a couple of seconds to finish. And then just click on Flash Firmware, and it'll start. This could take a couple of minutes. You see right now it's saying flashing, verifying, and programming successful. So the flight controller has been what's called flashed. Okay, once you've done that, don't connect, just close iNav configurator, restart it. You should now see a COM port right here. I happen to have COM 6 in 57,600 transfer speed. I'll connect. What we get prompted with now is a question, what kind of an airplane do we have? Well, the one we're doing is a Dolphin, so that would be an airplane without a tail. I know I've been saying it's got a tail and it's got fins, but those fins are not actually functional. All of the controls are on the what we call the ailerons of the wings. In a normal plane with a tail, you'd have a rudder, an elevator, that kind of thing, but we've got a plane without a tail, so click on that one. And it's going to save some default settings to the flight controller board. Okay, what we now have to do is to configure some of the initial configurations, which is, you'll see here we've got the runtime calibration is not done. We're going to go up here to calibration and do that now. The other thing we haven't calibrated is the accelerometer. That's the device that allows the plane to know what orientation it's in, how fast it's going, all kinds of stuff like that. It's kind of keyed to the earth like a compass and a GPS, but it's very, very sensitive instrument. So you click on calibration right here. Okay. Then you have a panel come up that says place the flight controller in, we're going to have to place the flight controller in different orientations to train the software inside where it is in space. So just click OK on that. Then click on Calibrate Accelerometer. You're going to now see a step which it already has done, it looks like, the first one, because I'm holding the flight controller in the upward position. So hold it upside down now, as the depiction shows, as level as you can. Don't move it around. Calibrate again, calibrate accelerometer. It'll now say, I know how I am upside down. I know what that feels like. Then you want to hold the flight controller to the side, okay? So you see the arrow on the top of the flight controller. Just place the arrow in the same direction and calibrate accelerometer again. It'll do that one. Go to the next one, which is upwards, like that. Hold the device upwards, click calibrate accelerometer. Then it wants to go sideways to the left. Hold it left, like that. Click accelerometer. And it wants to know what down feels like. So put it in the down position and click on Calibrate Accelerometer. It says calibration finished. Check if values have been saved. They have. You can go down and have a look, but it's always done. I've never had problems with that. And if you go down here, you'll see that it's put the gains that it needs to know at what position in space it is, whether the plane is upside down or whatever. So, does it really know? Well, if we go over here and we hold the flight controller in the right position and we go back to setup up here, you see that, yep, the plane is now, it knows it's flat and level. If I turn left, it goes left. If I turn right, it goes right. If I go up, it goes up and down, down, upside down. It knows now where it is in space. Job done. Now you can disconnect and we'll go on to the next step. Okay, this pretty much covers the initial configuration of the SpeedyBee flight controller board, the F405 Mini Easy Wing. Beautiful little device. Like I said before, the only little problem I have with it is where they place the SD card, but that's something I can work around. I can either take the plate off the top and take it in, put it in, take it out, or I can just use a tweezers maybe, and from the side I can put it in. Other than that, next step we're going to do is to look at placing the components in the aircraft, flight controller, GPS, VTX. We have the escape installed, the motors installed. So the basic components of the plane, we'll look at how they're going to be installed in the next session, which will be session 4. Hope you enjoyed this. If you like it, give me a like, thumbs up. See you in the next one, guys and gals. Bye.